This is Group ME, MfgE, MSE, and we will be discussing the process of how stainless steel is fabricated. First of all, what is stainless steel? Stainless steel is an alloy of iron with a minimum of 10.5% chromium. Chromium produces a thin layer of oxide on the surface of the steel, known as a passive layer. This prevents any further corrosion of the surface. Increasing the amount of chromium gives an increased resistance to the corrosion. The presence of the stable film prevents any additional corrosion by acting as a barrier that limits oxygen and water access to the underlying metal surface. Stainless steel is commonly used for building structures due to its resistance to corrosion and rust. It is also commonly used in hospital plumbing due to its non-porous and easy-to-clean properties. For the raw materials, we will be using chrome, nickel, silicon, and we will be reusing scrapped as well as excess steel from previous processes. In this process, we will be utilizing the electric arc furnace. As the name suggests, it will require electricity. The hazards it produces would be slag and loud noise. The electric arc furnace works by heating charged material by means of an electric arc. The electric arc works by breaking down gas that produces an electric charge. The furnace operations are, in chronological order, furnace charging, melting, refining, deslagging, tapping, and furnace turnaround.
Good morning. I am Erwin Kabanban, and I will be talking about the processes of continuous casting, hot rolling, heat treatment, descaling, and cutting. To start, the continuous casting. After the raw materials have been melted, the molten steel undergoes the process of continuous casting. This process forms the molten steel into their semi-finished forms of blooms, billets, slabs, and tubes. The hot rolling process. After the molten steel has been formed into blooms, billets, slabs, and tubes, it will then proceed to the hot rolling process. The hot rolling process is a metal forming process wherein the hot steel's thickness is reduced by rolling it into a pair of hot rolls. The hot rolling process will produce steel in the form of bars, wires, plates, and sheets. Furthermore, as the two rolls operate, eventually they would need to be lubricated with oil by a worker, in which case the worker must take every precaution, as the hot rolling process can produce hazards like eye injuries and burns caused by flying objects, acute dermatitis, severed limbs, and even hearing problems due to the noises produced by the hot rolling process. These hazards are categorized under physical and chemical hazards and under the OSH rules of 1080 for PPE, 1120 for hazardous work process, and 1940 fire protection and control. Such hazards can be prevented by taking precautionary measures, following the OSH rules, having knowledge of the work process, and wearing personal protective equipment. The heat treatment process. After the hot rolling process, the formed steel will undergo a heat treatment process, where the steel is subjected to heating and cooling under controlled conditions. What this does is it alters the physical and chemical properties of the steel. Some inputs required for the process are water for cooling, and the output of the process produces the heat-treated steel. The descaling process. The heat treatment process produces an oxide scale buildup, which is a waste, which the descaling process will remove. This waste is removed by various ways. The most common way is using water or the pickling processes. The pickling processes present hazards to the workers and facilities due to the acids used, but we will be talking about this more later on. Let us now proceed to the cutting process. After descaling, the uniform and clean steel will undergo the process of cutting. The steel will be cut in different dimensions based on the preference of the client. Furthermore, the cutting process also presents a variety of hazards to the worker. There are different cutting processes, like the mechanical cutting, flame cutting, and plasma jet cutting, all of which produce dust and fumes which can be inhaled by the worker and cause severe respiratory problems. In addition to that, the process can also cut the worker, which can lead to severed limbs. However, there are also ways to prevent these hazards from happening, one of which is to wear PPE, of course have knowledge of what to do, and maybe some machine guarding to prevent unwanted accidents in the workplace.
After the steel has been cut, it will undergo cold rolling. Cold rolling technology refers to a process whereby steel or stainless steel metals are rolled at room temperature rather than being heated at 1100 degrees Celsius. Rolling steel at room temperature by passing it through rollers enables shaping. Furthermore, this thermal treatment can be used to produce flat sheets of metal, coiled products or sections. The raw material is thereby passed through rollers below its recrystallization temperature of the relevant type of steel or stainless steel. The crystalline structure is also deformed. Additionally, the grain size is reduced, resulting in increased strengthening. The steel must be passed through the rollers several times to obtain the level of thickness or the shape required. This can take longer than the hot rolling process. Cold rolling requires oil lubricant and then produces cold rolled steel. The hazards of this process are acute dermatitis, noise, and nip points. Next, after the cold rolling, polishing takes place. Polishing are processes for improving the surface conditions of a product for decorative or functional purposes. The various techniques are abrading operations, although some plastic working of the surfaces may occur, particularly during buffing. The process causes some plastic working of the surface as metal is removed. A mechanically polished surface yields an abundance of scratches, strains, metal debris, and embedded abrasives, and always distorts the metal surface. Burnishing metal by lapping or buffing decreases the micro-inch roughness and improves the image-defining quality of a surface, but it never completely removes the debris and damaged metal caused by polishing. After the process, it produces polished steel. Grinding is a subset of cutting, as grinding is a true metal cutting process. Each grain of abrasive functions as a microscopic single-point cutting edge and shears a tiny chip that is analogous to what would conventionally be called a cut chip. After the process, it produces ground steel. The hazards of this process are dusts and fumes. Galvanizing is the process of coating iron and steel with zinc, which alloys with the surface of the base metal when immersing the metal in a bath of molten zinc, sinking at a temperature of around 840 degrees Fahrenheit. Like other corrosion protection systems, galvanizing protects steel by acting as a barrier between steel and the atmosphere. However, zinc is a more electropositive metal in comparison to steel. This is a unique characteristic for galvanizing, which means that when a galvanized coating is damaged and steel is exposed to the atmosphere, zinc can continue to protect steel through galvanic corrosion. The pickling process is used to remove a thin layer of metal of the stainless steel part. This is different from the descaling process, which removes visibly thick oxide scale from the stainless steel part. Our pickling solutions for stainless steel are mixtures of nitric acid and hydrofluoric acid. Corrosion on the contracted part can occur if the process is not done by a pickling specialist. After the process is finished, it produces the finished steel. The hazards of this process are the acids that can be corrosive to the skin.
Conveyor's belt are commonly used to convey items with irregular bottom surface, small items that would fall in between rollers, or bags of products that would sag between rollers. Belt conveyors are generally fairly similar in construction, consisting of a metal frame with rollers at either end of a flat metal bed. When using a conveyor, wear hard hat and safety shoes. Tie back long hair. Know the location of the emergency shut-off device and how to use them. Do not wear loose clothing or jewelry. Do not climb on the conveyors. Wrapping. Produce wrap steel. Using the following personal protective equipment prevents needleless injuries when manually moving materials. Hand and forearm protection such as gloves for loads with sharp or rough edges, eye protection, steel-toed safety shoes or boots, metal fiber or plastic, metatarsal guards to protect the instep area from the impact or compression. Conveyor belts produce wrap steels. Use guard pinch point on a roller and wheels and between the conveyors and receive table. Provide adequate guardrails along sides to prevent all objects from falling off. Provide retarders if heavy objects are conveyed. Ensure there are warning devices near the receiving areas if you cannot see the package moving on the conveyors. Ensure draft check are installed where conveyors pass through firewalls or floor. Stocking. Produce stock steels. Make sure to wear proper PPE to avoid incidents or accidents. And lastly, delivery. Produce delivered steel. Employers can reduce the potential for a delivery driver injury or fatality with these steps. Check driving records, provide training, avoid weapons, avoid late night, set a casual dress code, use camera and GPS.